Let us analyze isobaric process in detail. So when a gaseous state is changed from P1, V1, T1 to a final state such that the pressure remains constant for the gas. So pressure P1 remains same, volume changes to V2 and temperature changes to T2. So initial to final state, we can easily relate the remaining parameter V1 T1 and V2 T2. Here if P is constant, we can write delta P is 0 as well as dP is 0. That means pressure is not changing at any intermediate instant of time also. Here we can write by mole conservation V1 by T1 is equals to V2 by T2, which is the relation we use for relating these thermodynamic coordinates. Now, if we just analyze the same process which we are denoting as, which we are calling as the thermodynamic process, by first law of thermodynamics we can state dq is equals to du plus dw. Now, in this situation, as we know this dq we can write here and Cp dt because pressure is constant, so its applied can be written as Cp dt. Internal energy change can always be written as Cv dt, and work done by the gas can be written as Pdv. This is the relation we use for analyzing various kind of numerical applications and relating thermodynamic coordinates corresponding to the process. In this situation, if we talk about all these thermodynamic parameters of the gas, so again we can state if we talk about heat supplied, Q can be written as integration of dQ, which is integration of NCP dt from T1 to T2. So this can be written as NCP T2 minus T1. This is the result we use for calculation of heat supplied. If we find out change in internal energy, delta U can always be written as for all kind of processes NCV T2 minus T1. So this will give us the amount of change in internal energy for the process. And if we find out work done by the gas, so work can be written as integration of PdV from V1 to V2. Here as pressure is constant, it can be simply written as P V2 minus V1. And here PV2 or PV1 by using gas law we can write as nRT2 and nRT1. So this can be written as nRT2 minus T1. So always remember in case of an isobaric process, work done can be written as P delta V or nR delta T. Both are the relations which are useful for calculation of work done in an isobaric process. Here also Cp and Cv you can substitute in terms of gas constant. So this can be written as N gamma R by gamma minus 1 delta T, and this can be written as Nr by gamma minus 1 delta T. So always remember for a given thermodynamic process, these are the three thermodynamic parameters which are quite important for analyzing different numerical applications. Now in sequence, we can discuss about indicator diagram for isobaric process also, because it is always useful to study indicator diagram corresponding to each process we study. As we know in isobaric process, pressure remains constant. So the indicator diagram is again quite simple, in which the pressure of gas remains constant. So its state 1 is changed to state 2 with a horizontal straight line ID, in which only volume changes from V1 to V2. In this situation, you can easily see if we find out the area under this PV curve, this area will give us the amount of work done by gas. As the ID is going from left to right, the ID is representing expansion of gas, so this work can be written as P into V2 minus V1. This is the area of this rectangle, which is obviously positive. Sometime it may happen that in this situation we can see delta P is 0 as well as dP is 0. Like sometime it may happen in a particular process, delta P is 0 but dP is non-zero. Like this situation, if initial and final states are having same pressure but the curve is moving like this. So in this situation we can write delta P is 0 but there is not an isobaric process because here dP is non-zero, the pressure is changing at intermediate states. However, the initial and final states are same. So if we find out the work done in this situation, certainly it is not equal to this P delta V. Here we can write work done will be less than P delta V because this much amount of work is less compared to this case, and this is a non-isobaric process. Several students might get confused that if delta P is 0, it gives us an idea about isobaric process, which is not true. The absolute way to check whether it is isobaric or not is dP equal to 0. At every instant, the pressure should remain constant. Then only we can call it an isobaric process.